Hello, this is Python Statistical. In a prior video, we looked at reading in multiple Excel spreadsheet files from a directory and subdirectory using the os.walk method. In this video, we'll look at how to make use of that data. That data is the Australian Bureau of Statistics Labour Force Australia data. So let's run this program again just to remind us what it produced. So it's reading in all those Excel spreadsheets, which contains the published labour force data, and we've stored that in a dictionary, and the dictionary contains all the Pandas data frames of the published data, and we use the catalogue number as the key. So this one is table 1. We double click on it, we can see that from 0 to 9 we have the column description of the published data, and then from row 10 is where the actual data starts. Now in this form it's very hard to use in Python. We need to convert this column description into a variable name that we can use. So a while ago I wrote a function that actually converts these column descriptions to variable names, and that was one of my first series of videos I produced. I'll link a description below which covers the basics of how we can do that. So now I'll just demonstrate this function and then how we can use it to extract the data and be able to do analysis on it. So here is the program that I'll use to implement the function that will convert the column descriptions to variable names. The actual function name is Spreadsheet to Pandas. This is version 3_1. So I call this function Spreadsheet to Pandas, and I output the published data for a particular catalogue number into a Pandas data frame, and also have something called the variable map, which maps the column description to the actual variable name. Also in this function I've implemented the prefix functionality that allows us to read in multiple data worksheets, as I described in the previous video. So after running this function, I'm going to print out the results. So I will print the variable map. So that's located at index 1 for the first table and for employed total persons trend. So the variable name var_this contains the actual column description. Then I'm going to actually print the actual data, the published data, and that's stored in the 0 index for that table 1. You may notice that this variable name has a number on the end. So if you have like thousands of columns that you want to convert to variables, you may want to have short variable names, and that ensures that you have unique variable names by adding a unique number on the end. So let's run this code and see what we get. So it's just run, and it's printed out the published estimate for employed total persons trend, as we can see here. So the year, month, and so on. So now our Python dictionary has become a tuple. So let's have a look at that. So we have an index 0, that's where our published data is kept, and we have the index 1, that's where our variable map is stored. So let's have a look at the published data, and we'll look at table 1, and we can see now that we actually have a variable name instead of the column description for each of the published estimates. So now let's have a look at the variable map. So open that up, and for table 1 we can see now that each of our variables, which is stored in the index as an index, has a column description attached to it, stored under the var_disk variable. So this brings us to the end of this video. In the next video I'm going to actually plot data. I'll plot the original seasonally adjusted and trend on the same graph to see what it looks like. So if you like this video, give it a thumbs up. If you disliked it, give it a thumbs down. And if you really like it, please subscribe to Python Statistical. Thank you for watching.